This video deals with evaluating expressions, and we're going to start right off by defining what an expression is versus an equation or inequality. So an expression is just a collection of values, and it doesn't have to be hard numbers or that sort of thing. It can be letters as well. But it's a collection of values, coefficients and variables, and operators. You do something. It doesn't relate to it. It doesn't say, oh, well, it's like this. No, there's no like. It's just something you do. So, and then it's a collection of values and operators and other non-relation symbols. Relations are equals, not equals, greater than, less than, that sort of thing. Add, subtract, multiply, divide. Those are all of our traditional operators. To square something would also be part of an expression. If you had some other weird function like sine or cosine or tangent, if you've studied trig, those can be thought of as expressions. As long as you're not relating it to some other thing, life is good. It's an expression. For the beginnings, if you are just coming into algebra, that sort of thing, then if it doesn't have an equal sign, it's an expression. If it does have an equal sign, on both sides you have expressions, but the whole thing is known as an equation. So an equation or an equality is a relation of two or more expressions. It's not limited to two. Typically when you start out, if it's using just equals, but you can also have less than, greater than, as long as you're in the real numbers. Less than or equal to, greater than or equal to, or not equal to. Those are all relations. We're just trying to make the difference between expression and equation. So as long as it has a relationship symbol in there, it's an equation or an inequality. What you do is regarding the two, and this is in that light blue kind of tealish looking thing. You evaluate an expression, meaning you have to be given the values of whatever variables are located in it. If you have an equation, you solve that. So when we are discussing these expressions, we're not solving for anything. You're going to get a solid number. You're not going to get x equals. We're already giving you that. But you're going to get just a number, and that's it. So let's take these first couple here. Go ahead and use green, I guess. We haven't used that yet. Whenever you are making a substitution, this is for all substitutions. For those of you in a slightly advanced class, yes, this includes if you're substituting an expression in for a variable. Whenever you are making a substitution, you are making sure that you always do it in parentheses. Always, 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 forever, never, never, amen. If you don't, bad things will happen. We will see what happens later. But when we put this in here, it's really 3 times 1. So 3 times 1 is 3, plus 2 is 5. The evaluated expression is 5 when x is 1. Over on the next one here, we have y is -1, so we just write that in as inside parentheses, minus 10. Now, -7 times -1 is going to give us a positive 7. Minus 10, again in that order of operations, that's going to give us a -3. So watch out for those order of operations. Every other rule applies as far as arithmetic goes. Yeah, we don't want to conquer the big one yet. So these next two are going to show you the difference between putting things in parentheses and not putting things in parentheses. If you do not put these numbers in parentheses, then you're going to come up with something that's not right, especially on the second one. Your calculator will do things correctly, but you got to tell it how to do it. Even the advanced calculators, they'll do the order of operations. If you don't put in the parentheses when you make the substitution, they'll do it wrong. It's okay. It's what happens. All right, so anywhere we see an x, we're going to put a 2 in parentheses. So we have in parentheses 2, and then that whole thing gets squared. Notice how whatever x was gets squared. That whole thing gets squared. -7 times 2 plus 3. So this is really 2 squared, which is 4, minus 14 plus 3. 4 and 3 is 7, minus 14 is -7. Okay, so now we plug in a negative 2. In parentheses, negative 2 squared minus 7 times negative 2 plus 3. Negative 2, the quantity of it, squared, is negative 2 times negative 2, which gives us a positive 4. Negative 7 times negative 2 is a positive 14. And then we add 3. 4 and 14 is 18 plus 3 is 21. You're like, but I didn't get that. If you didn't get that, most likely what happened is that you didn't put parentheses around the negative 2. And so if you don't put parentheses around negative 2 and you just do this in your calculator, times negative 2 plus 3, it's going to do the negative 7 times negative 2 correctly. But this answer, specifically, negative 2 squared, is going to give you negative 4. That's not right, though, because we're squaring the x and we're squaring the negative along with it. Negative 2 quantity squared is positive 4. This has to do with the order of operations. There should be a few videos out there that discuss this. I was well into my bachelor's before somebody finally answered this, and I asked a lot of professors this, and I don't know if they just didn't want to answer me or they didn't know. But as I matured through mathematics, I found out that there's really no such thing as a negative number. What it is when we write negative 2, and I know this is a little off topic, but it helps explain what's happening here. When we write negative 2, what we're really saying is that this is negative 1 times 2. So there's multiplication happening there. In this first example here where you don't have parentheses, that means that you have negative 1 times 2 squared. The exponent comes first in the order of operations, so you square the 2 to get 4, then you multiply by the negative, giving you negative 4. In the second example, though, when you have negative 2 in parentheses, you do what's in parentheses first. So you multiply those two things first, then you square it. That's going to give you a negative times a negative, which is a positive. That's why you get the difference between the negative 4 and the positive 4. So keep that in mind as you're working through these problems. Be very careful and always use parentheses. Always, 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 forever, never, never, amen. All right, last one. I picked this one because it's gross. It looks horrible. It only looks horrible because it is. But there's probably other reasons. Anyway, this is an order of operations issue as well as just raw substitution. So here we go. Negative 2. We're not doing any substitution right now. This is just writing stuff down. Minus 2. Now, when we go into the A's and the B's, A is 10, so we put that in as parentheses in 10 and minus. B is 3, minus 7. I know somebody's going to be like, you don't need the parentheses. In this example, you don't need the parentheses, but later on you will, and so that's why we always do it. That way we never change. Because war never changes. Anyway. 10 minus 3, so we do the inside first. This whole piece right here, 10 minus 3 is 7, minus 7 is 0. So we're going to have negative 2, and in parentheses, or brackets, we're going to 19 minus 6, in parentheses, 4 minus 2 times 0. Well, 2 times 0 is just 0. So this stuff here is all going to be 4. So we say negative 2, and then in brackets, 19 minus 6 times 4. We don't need the parentheses because we already took care of that by doing the stuff inside. Then we're going to take and we're going to multiply these two first, so we get 24. 19 minus 24 is a negative 5. So we have negative 2 times negative 5, which finally gives us a positive 10. So this whole mess that started off as this god-awful thing ended up being 10. It happens. It's one of those weird things in math. So that's it. This is expressions. Just evaluate them. You just shove the variables or variable in there and then evaluate it. Always making sure substitute in parentheses. Please use parentheses. Take care.